In this video, I've put some practice questions on mechanical comprehension for you to prepare for the ASVAB test. A string of 6 gears exists, with each gear turning in conjunction with one another, which gears operate in the same rotation. So the answer here is gears 1, 3, and 5. Because gears must work in harmony with one another, gears turn opposite the direction of their partners. So for this reason, gears 1, 3, and 5 turn in the same direction, while 2, 4, and 6 turn in the opposite direction. Which is the best description of centrifugal force? The force responsible for the changes made to water during distillation, the response of bodies with inertia to the straight moving or curved behavior of their container, the relationship between two opposing forces, or the force by which bodies are propelled forward. The answer here is this one. The response of bodies with inertia to the straight moving or curved behavior of their container. So what is a centrifugal force? The centrifugal force is an apparent force caused by inertia on an object moving in a circular path, and this force points radially away from the center of the circle. What is the gravitational force between two 2-kilogram masses located at a distance of 50 centimeters? Now, to solve for the gravitational force, we can use the formula F equals G m1 m2 over r squared, where F is the gravitational force between two masses. M1 and M2 here are the masses of the two objects, and then in this case we're given 2 kilogram each for the masses, and then G here is the gravitational constant, which is equal to 6.674 times 10 to the negative 11 cubic meter per kilogram per second squared. And then r here is the distance between the centers of the masses, which is 50 centimeters, and we can convert this to 50 centimeters. We convert this to meter, which is just equivalent to 0.5 meter. Alright, so let's now solve for the gravitational force by plugging in all of the given values. Okay, let me delete this first. Okay, so our gravitational force F is just equal to G, which is 6.674 times 10 to the negative 11 times mass 1 and mass 2, that is 2 kilograms, 2 kilograms, divided by 0.5 squared. We should put the units here. The unit for G is, this one is cubic meter per kilogram second squared, and this one is kilogram, and 0.5 is in meter, so there will be meter squared. So the units here, some of the units here cancel out, like kilogram and then meter squared. Then we'll be left with kilogram meter per second squared, which is just equivalent to Newton. And you can solve this using your calculator multiplying 6.674 times 10 to the negative 11 times 4 divided by 0.5 squared, and this would give us an answer that is equal to 1.1 times 10 to the negative 9 Newton. So the answer is this one. How does oil function in a machine with a series of moving parts? Oil serves as a fuel for moving parts in a machine. Oil functions as a cleaning agent, allowing all moving parts to remain free of dirt and grime. Oil functions as a source of lubrication, allowing moving parts to function as a single unit. Oil provides a source of power when paired with fire. Well, in a machine with many moving parts, oil typically serves as a source of lubrication. So the answer here is this one. Oil functions as a source of lubrication, allowing moving parts to function as a single unit. Which of the following materials serves as a thermal conductor? Metal, acrylic, paper, wood. So among the choices here, metal is the sole material serving as a conductor, while the rest of the materials here, acrylic, wood, and paper, they will all absorb and retain heat or cold rather than act as a conductor. A load is placed on the right end of a lever which is resting on a fulcrum that is located 5 meters from the right end. How far from the fulcrum must an effort force be applied so the lever has a mechanical advantage of 5? So how are we going to solve for the mechanical advantage? The mechanical advantage on a lever can be defined as mechanical advantage equals d of f over dl. So dl here is the distance of the load from the fulcrum, while df is the distance of the force. Now to find the distance of the force, that would be the df, we can derive this equation. We can multiply both sides by dl. So df would be equal to mechanical advantage times dl. And then we plug in the given value. So we're given here a mechanical advantage of 5. So that would be 5 times dl, which is, okay, given us as 5 meters. So that would be, the distance of the force would be 25 meters. So the answer is this one. What determines the speed of a pulley system? The size and ratio of all pulleys involved, the length of the rope or belt used in the pulley system, the size of the pulleys as a whole, or the material used as a belt, such as leather and rubber. The answer here is this one. The size and ratio of all pulleys involved. So the size and ratio of all involved pulleys determines the speed of a pulley. A large pulley driving a smaller pulley, for instance, will result in greater speed, as the large pulley's single revolution will result in multiple revolutions for smaller pulleys. So the length and material of the belts are not a factor here, this one, nor is the size of the pulleys as a whole, rather than in relation to one another. Pulley systems require pulleys to rotate in the same direction. How can they escape this rule? To violate this rule, pulley systems must use twisted belts. To violate this rule, pulley system belts must be reversed. This rule cannot be effectively violated. To violate this rule, pulley systems may be used in conjunction with gears. Alright, the answer here is this one. To violate this rule, pulley systems must use twisted belts. The design of pulleys prohibits the pairing of pulley and gears, and a simple reversal of belts will result in synchronized reversal of all pulleys. So to violate this rule, a belt must be twisted so each pulley rotates in opposite directions.